whatever success we may have had with SolFocus, or SolFocus has had, first of all, can be recreated anywhere that has a good scientific infrastructure. And India definitely has it. I see it here. I've seen it at IISc. I've seen it at the Nehru Center. It's fabulous. So there's no question about that. Now specifics. Our experience with SolFocus was they're coming to us in Israel and saying they wanted to have a major impact in solar power generation, and they had identified concentrated photovoltaics. So now I'll give you the bullets you asked for, the bulleted evolution of this. The first is you have to understand the wish list. What's the company's wish list? The second item will be, can we invent all the new notions, optics, materials, whatever, that are needed to satisfy that wish list? And the third is, can we build and generate proof of concept for this? Tabletop, lab bench proof of concept, do the physics work. If all these three work out, then you're in great shape. Then the problem is mainly money and production engineering. The fourth stage then is, can we scale up to large pilot plants, and then proof of concept in the field at a multi-megawatt scale. So those are the four bullets. Now the first part, SolFocus came to us. It wasn't SolFocus then. It was two really charming and bright engineers, Gary Conley and Steve Horn, in a garage in Saratoga, California, who came to us in stable care and explained why they had concluded that the direction they had started would probably not succeed. And I said to them, give us a wish list. You've probably never even articulated this for yourself. Think, dimensions, materials, costs, processing, all of these. And we'll tell you what violates the laws of physics and we have to toss out the window, and what does not, and then we're only limited by our imagination. And they were able to do this, and they were able to do it rapidly. Once we understood this list of constraints, we saw that there was nothing in the literature, off the shelf, so to speak, that could satisfy all the constraints. So they had not missed the boat, so to speak. And for us, it was a challenge. Could we invent a fundamentally new class of optics, tailored to the current generation of ultra-efficient solar cells that could satisfy their wish list, and thereby translate into affordable, reliable, and reliability is no less important than affordable here, reliable solar power generation. And this shows a bit of the evolution. We invented their first generation, what they call Generation 1, for the 1 centimeter squared or 100 millimeter squared solar cell technology. SolFocus makes everything except the cells. That's quite a complex epitaxial-based technology. At the time, there were only 3 or 4 companies in the world that could produce it. Today, it's more like a dozen, and it's growing every year. So they had to import that cell technology, and they wanted to build everything else. We invented a fundamentally new class of optics that satisfied their whole wish list, or the wish list at the time, because you learn lessons as you go along in life. With this, we were able to then build prototypes. During my sabbatical at the University of California with Roland Winston, we were able to find companies that could produce the basic components, and by the time I left, here is a module of 16 of these miniature optics. Each one is 31 centimeters, 1 centimeter cell, and it generated 240 watts of power as designed. So this is the tabletop device that works, so to speak. While we were at it, we also were interested in the millimeter scale technology, and Roland and I invented yet another class of new optics based on all glass optics, which they were excited about in terms of the ease of fabrication, no alignments, ease of production. Glass is a very cheap material. It's cheaper than polymers, incidentally, in terms of the raw material. And we succeeded in that, and that's what Steve Horn is holding here, but this is still a prototype. So from that stage of successful benchtop prototype, meaning you start with a wish list, you invent some new science, you build it, it works, end of this stage. And now I fast forward to the end. This is a photo of the type of multi-megawatt systems that SolFocus is now installing. This is in Spain. It's about 200 kilometers south of Madrid. They now have factories for different parts of the technology in Arizona, in California, in China, in India, as well, in Delhi. This is the technology that they have now converged upon. However, for me, the story doesn't end here. For them, at the moment, they've basically frozen R&D, research and development, and they want to produce as many of these as reliably as possible. Incidentally, the reliability here has been checked, and it's excellent. The system went online in November 2008. We're now sitting 14 months later. There are no problems. The output of the system is essentially 100% of what was projected. That's rare. In physics, something's always supposed to go wrong. Here, fortunately, it didn't, but that's to the credit of Gary and Steve and how meticulously they demanded that every component be reliable before they would dare install a system. Now, in the process of producing these modules and these systems, they revised their wish list. There were certain items they were more concerned about, materials reliability over 20 or 30 years. No one knows the answer, but there's reason to be concerned. So they asked, for example, could we eliminate some of the alignments in the production process? A simple single mold injected element. Could we eliminate an optical bond between a solar cell and a piece of glass so that there would be no danger of these separating and degrading performance? Could we design a system which, if it were off axis, unintentionally, but it always happens in the field, this is always supposed to be pointing directly at the sun, but the tracker stops working and the sun continues moving. Some systems, not SolFocus, but some systems were destroyed because when the sun focuses off axis, it focuses on a non-cell element and destroys it. So can we design optics which are basically fail-safe? So now the wish list is expanded, and we go back to our drawing board, so to speak, and we invented some new optics. Indeed, these are papers we've published and patents that have been taken out between my university and SolFocus. And it's an ongoing relationship which has been immensely gratifying, but more than that, rewarding scientifically. I can have my graduate students and my colleagues working on this with me. We're developing fundamentally new optics, and it's so rewarding that it translates into a real device that can produce solar power for the planet.